A force of 20 newtons is pulling on a 2 kilogram block, which is attached to a 1 kilogram block. The coefficient of friction is equal to 0.2. Assume the surface is not frictionless, so you must account for friction when summing the net forces on each block. Find the tension in the rope between the blocks and the acceleration of the system of the blocks. So we know that here's a drawing of our diagram, and we know that they gave us the coefficient of friction, which is mu of k, and it's equal to 0.2. So we know force is going to be dissipated while it's being pulled, each block. So we know that with friction, we're going to have to find the force of weight and the net normal force, which is perpendicular to the surface. So first, let's do the force of weight. We know the force of weight is equal to mg. So let me write that up here. M being the mass, g being the gravity constant. And we know here, let's just assume gravity is 10. So we got 10 newtons of force of weight, and we got the force of weight over here to be equal to 20 newtons. Again, 2 kilograms times 10 meters per second squared. It could be 9.8, but let's just round it up. Now we know that since it's lying flat horizontally on the surface, the normal force is perpendicular to that. And we know that the force of friction is equal to mu of k times f of n. So here we got f of n being equal to force of weight, so it's 10 newtons. Over here we got the normal force equal to 20 newtons. There we go. Now we have all we need to solve for the forces. Again, let's write sigma f equals ma. Always do that. And let's try to find the contributing forces here. So we know we're pulling with 20 newtons. And logically speaking, do you think the friction for each of these blocks is going to contribute or go opposite of the direction of the force? Well, since it's friction, it's obviously going the opposite, so let's subtract. And now plugging this in, we got mu k, which is what we were given, 0.2. And now let's add up each box. Let's go left to right. So we got 10 here, 10 newtons. Minus, again, 0.2 for mu of k. And now this time we got to do 20 newtons. And now, since we're doing the sigma force of the entire system, let's write that here, system. Force of system, mass of system, acceleration of system. We got to use the mass of the system, which is just the entire mass, which is 1 plus 2 equals 3 times a. Now let's simplify this a little bit. We got 20 minus 2 minus 4 equals 3a. Again, let's simplify that one more time. What's 20 minus 6? We got 14 equals 3a. Divide that by 3. A equals 4.67 meters per second squared. That's our answer, but that's not the entire answer. We got to also find the tension in the rope between the two blocks, so T right here. Always remember, find acceleration before tension. You can't do it otherwise. So let's hone in on one block. To find the tension, you want to look at another free body diagram of a block. But to make it as easy as possible, let's choose a block which has the least amount of forces acting on it. So we can see there are a total of 4 forces around this block. So let's choose this one where it only has 3. So let's draw the 1 kilogram block again. And we know that there's going to be tension. We know what the normal force is, 10 newtons. We know what the weight is, 10 newtons. And we also know what the friction is, which we calculated back here when we did 0.2 times 10 is just 2. So we can cancel the vertical components of it because we're only looking at the horizontal components, which would contribute to acceleration and tension. Otherwise, it wouldn't. If it's perpendicular, it won't contribute. So now moving over here, we can see that we have our tension. We got to write sigma f equals ma one more time. Don't worry, this is the last time we're doing it. And we know that the leading force is going to be the tension, the thing that's pulling the last block forward, but that's what we're solving. We know there's going to be one non-contributing force, or anti-parallel force if you will, that's going to be 2 newtons of friction. From over here, you see it's going to resist going to the right. And now we equal that to the mass, which is 1 kilogram. And we were given A over here because this is the entire acceleration of the system. It's uniform, so it's going to be 4.67 meters per second squared. So now, if we simplify this, let's set T over here. So we got 1 times 4.67, which is again 4.67, and now we're simply adding 2 to that. So now we know that the tension is 6.67 newtons between the 2 blocks. So it would be 6.67 that way, and it would be 6.67 that way. It's uniform along the rope. So yeah, there you go. We found the acceleration, we found the tension, and again, when you're considering these diagrams, only look for the weight of the forces and then focus on the acceleration and tension. I hope this made it a little easier. If you have any questions, put it in the comments below, and thanks.